Right, here's my next project. It's hard to see because of the dumb way that I wired it, but this is just a three, 3-digit display that's just counting up, from 0 to 199. I can actually reset it right here. So 000, and when I release the button, it starts just counting and counting and counting. And the way that it works, and I wish I had wired this differently because there's definitely a much prettier way to do this, is that I basically, let me get my little pointer here. I have these 4026 integrated circuits, which are each decade counters. So each one of them takes a signal into its pin number 1, or pin number 2. Yeah, pin number 1, and that causes it to internally count up. But what counting up means for it is that it emits on 7 or 8, I think 7, different other pins, connect to an LED that's inside each one of these segments of the 7 segment number. So when it's showing a 2, that basically means that internally it knows to send a positive voltage on, call it, like if we look at this 3, it's 1, 2, 3, 4, 5. So 5 of these pins are emitting a positive signal along these wires that are connected. So for each of these ICs, we have 7 wires connected to each of these numbers in order to make it render something. Now, signal to the 1 pin makes it count upward. This pin is the carry pin, meaning like it carries over when it reaches 10. So, and I don't actually remember. Let me see. I can probably tell. Oh, I have it right here. You can see this red connection. It's on this pin, I think the 4 pin or the 5 pin. Basically, a positive voltage goes when this IC counts over to 10. It emits a pulse here to the number 1 pin of this one, which increases the next number in the sequence. When this one rolls over, you can see right here it has another same connection, emits to the 1 pin of this, which counts over this number. Now they're kind of reverse. This one, because it's the one that's receiving regular pulses to count up via this wire, it's actually controlling the rightmost number here, which is the lowest order digit. Then it carries over to this IC, which controls the next one, and then the last one, which controls the hundreds, controls the leftmost. So I could have probably reordered this. Realistically, I probably should have put the ICs up here and the display down here so that the wires would only run alongside everything, but whatever. And then here I have that trusty old 555 timer that's just working in astable mode to constantly emit regular pulses. It looks like it's doing about 4 or 5 times a second to the 1 counter here. So now I can actually remove this, and I'm going to violate my own rule. I might actually do this with these tongs. No, I'm going to do it by hand. Disconnect this, which should stop the timer, but the timer should stay on because it's still getting voltage. So come on, get out of there. Okay. Oh, so it zeroed out. I think I probably messed up a connection somewhere, but I do have these buttons set up. So if you look very closely, this the 1 pin should be connected, I think, to, where is it? This button here. So if I press it, every time I press the button, it should count up 1 more. This button hits the reset pin and zeroes them all out. How this is actually wired, it's wired to a reset pin. You can kind of see it, this yellow line. So it goes from positive voltage to this button via this yellow line to the, what is that? That's the, because it's 14 on, no, it's 8 pins on each side. So it's 16 pins total. So that's like the 15 pin or the 14 pin. But I connect all the 14 pins together. You can see the orange running alongside. So basically driving power by this 1 switch goes to the 14 pin of all 3 counters, which zeroes everything out. So there's one other neat feature of this, of the IC. Let me actually put this counter back in so the pulses are going back to this one. It's as though someone's pressing this button really quickly. This other button, you can see it's wired up to pin 2 via this green line, and it actually is called the clock stop pin. And what that does is we're still emitting those positive pulses to pin 1, but because I'm holding down the clock stop pin, it's basically telling the ICs to just ignore the fact that those pulses are coming. Kind of neat. So I'm not going to follow the rest of this project through. The project was originally supposed to be a reaction timer, so there would be another set of timer 555s that like start the clock, and then it's up to, and turn on a light, and then it's up to a person to press the like the clock off button as quickly as possible, and we would tune the timer so it would like time in milliseconds rather than, you know, however fast it's going right now. So you could basically flip on a light and then have a person turn it off, and the clock would stop at however many milliseconds went. Is, so, you know, a reaction timer. Anyway, I think I've learned enough from this, and I'm not going to learn too much more by doing that. Or maybe I will, I just won't make another video about it. Anyway, pretty fun. Way too many wires.